Okay, we are going to talk about the oxidation of alcohols. Now, when we're talking about here, we're talking about oxidation by mild chemical means rather than oxidizing by burning in oxygen. If you get any alcohol, they'll all burn quite easily with oxygen, as long as you set fire to them, so you have to provide energy. Pre-exothermic reaction, you're going to get CO2 and water. We're not talking about full oxidation, we're talking about much milder oxidation. Okay, oxidation with chemical oxidizing agents, in particular the one that we're going to talk about is potassium dichromate solution. Okay, so potassium dichromate solution. Okay, the obviously the potassium is going to be a K plus ion there, so what really is the oxidizing agent is the dichromate ion, 2 minus charge. That's orange. That's an orange colored ion in solution, and when it oxidizes things, it gets reduced itself obviously to Cr3 plus, two of them, and that's a green color. We'll just write a half equation for that. Generally speaking, when we're doing organic chemistry, we don't bother with half equations, but we'll do this anyway. We need to balance for the oxygen, so we want 7 H2Os on the right hand side. So that means we're going to need 14 H plus here. And if you check your charges, you'll find that's 6 electrons. Okay, so potassium, so it's the dichromate ion, of course. You notice here you need some H plus ions. So you need to acidify your potassium dichromate solution, and it's usually acidified with some sulfuric acid. Okay, so we have this orange solution, and we can oxidize alcohols with it. Now let's see what they're going to be oxidized to. Now that depends if they are primary, secondary, or tertiary alcohols. Now we've come across primary, secondary, and tertiary, so with respect to carbocations and with respect to like haloalkanes. So a primary alcohol is the carbon with the OH is only attached to one other carbon. In other words, the OH is on the end, so an example of that would be ethanol. That's a primary alcohol. Secondary, the carbon with the OH is attached to 2 other carbons. So the simplest secondary alcohol, I'll put the OH there, so that carbon needs to be attached to 2 others. So the simplest secondary would be propan-2-ol. And a tertiary alcohol, that's when you've got the carbon attached to 3 others. 3 other carbons. So the simplest tertiary alcohol would be, and that's, well, here's a carbon with an OH on it. We need to have a carbon attached to each of those. So I won't bother doing all the hydrogens. So we would call that, that would be methyl propan-2-ol. That's the simplest tertiary alcohol. Now, the way they're oxidized, whether it's a primary, secondary, or tertiary, when you react them with potassium, when you oxidize potassium dichromate, you get a different product depending on which, whether it's primary, secondary, or tertiary. Now, if you just recall, remember what we said about, we said with alcohols, with organic chemistry, we said that oxidation is adding oxygen or removing H. Okay, and obviously reduction is the converse of that. So let us have a look. what happens when we try and oxidize a primary alcohol. So let's clear that. Right, so primary alcohol, I'm going to do ethanol, sorry. Put that. So here is going to be ethanol. And we are going to warm up the ethanol with acidified potassium dichromate. And what happens is we are going to remove 2 hydrogens. Okay, so if you remove that hydrogen, now that means that here, that oxygen is not forming enough bonds, so it has to form a double bond. That means this carbon is forming too many bonds, so you've got to lose that hydrogen, one of the hydrogens. Okay, so I just get rid of those bits. So we're going to remove those 2 hydrogens, and so what we form is we end up with this, right, double bond oxygen there and a hydrogen in there. Now this functional group, this is called an aldehyde, okay? And that is the first time you've come across an aldehyde, I think, probably. An aldehyde. So let's call that, write down, that's a primary alcohol. And we're going to oxidize it to an aldehyde. Now we can oxidize that a little bit more, okay? We can oxidize it again, and this time, instead of removing hydrogens, we're going to add another oxygen, and the other oxygen is going to go in here. Okay, so you probably recognize this thing. Yeah, that functional group, it's a carboxylic acid, isn't it? Okay, a carboxylic acid. So a primary alcohol can be oxidized, first of all, to an aldehyde, and then oxidize a bit more to a carboxylic acid. And by the way, I just want to say, this C double bond O group here, this is called a carbonyl group, okay? And we need to just, so the carbonyl group, when it's on the end, it forms this thing called an aldehyde. Okay, so now let's see what happens with a secondary alcohol. So secondary alcohol, I'll do propan-2-ol. And we're going to do something very similar with that. We're going to heat that up with acidified potassium dichromate, and it's going to get oxidized. We're going to remove hydrogen. So we're going to remove the hydrogen from the OH. Now that means that that's got to form a double bond there, doesn't it? So that means that this carbon's forming too many bonds, so we've got to remove that hydrogen as well. Okay, so we're just going to remove those 2 hydrogens. Let's see what we get. Right, we get, that's a double bond, and we've got these here. Now, again, like the aldehyde, we've got this thing, which is called a carbonyl group. But when it's in the middle of a carbon chain like that, rather than on the end like the aldehyde, it's not called an aldehyde because it's slightly different chemical properties. It's called a ketone, and that's the first time we've come across that. So we've got a secondary alcohol. When you oxidize it to a ketone. Okay. Right, now let's see what happens with a tertiary alcohol. Tertiary alcohol is methyl propan-2-ol. Okay, so let's see what happens in the other 2 cases. Well, we oxidized it, heat with potassium dichromate, you remove that hydrogen off the OH, don't you? So that means that this would want to form a double bond to that carbon there, and then that carbon would be forming 5 bonds, so one of the bonds would have to break. One of these carbon bonds would break, and they can't, okay? And so what that means is you cannot oxidize a tertiary alcohol with potassium dichromate. Yeah, you can oxidize a tertiary alcohol by burning it in air, but with mild chemical oxidizing agents, you cannot oxidize. No oxidation, I'm going to write there. Right, so no oxidation. You can't oxidize it. So let's have a quick look at that. Let's summarize that, shall we? Sorry. Shrink that. So we get a nice little pattern there, don't we? A nice little pattern. We get a primary alcohol can be oxidized to an aldehyde, 2 steps. 1 step. Second step, oxidized to a ketone, to a carboxylic acid, sorry. The secondary alcohol can only be oxidized 1 step up, yeah. And this one can be oxidized no steps, okay? So we get a nice little trend there. Okay, let's just have a little think about how would you do these before we, how you could do this experiment. Right, a nice little test tube experiment. You get yourself a test tube and you put some ethanol in there. And we're also going to put in some potassium dichromate, and of course it's got to be acidified to do the oxidation. I'm going to color that in orange because that's what color it would be. Okay, so you're going to warm that up in a water bath. So you put it in a beaker. Put it in a beaker of hot water. So here's my beaker. Here's my tube. Okay, this is all hot water. And what you notice is that the color changes. It goes to the color of the solution. Well, it will go green. Because remember I said what's happened, the reason why it's green is because you've now got the chromium 3+ ion. The dichromate has been reduced to chromium 3+ ion, so you get this this color. So saying this is got ethanol in there. And what you'll smell coming out of this tube is you get a bit of a smell of rotten apples, which is due to the aldehyde, which is called ethanol. Okay, you get a smell of ethanol. If you leave it longer, you don't actually get. You might think, oh, you get a smell of carboxylic acid. Or carboxylic acid, you'd get ethanoic acid, that smells of vinegar, but you tend not to smell that. It doesn't oxidize it in the second step because this aldehyde is quite volatile and it just all comes out. Okay, it all comes out the tube and it doesn't hang around to get oxidized again further up to the carboxylic acid. But you will get an orange to green color change. When you do this. And this is quite a good test for, well, it will work for a primary, won't it? Yeah, because you can oxidize that. It will work for a secondary because you can oxidize that. It will not work for a tertiary because you can't oxidize the tertiary. So the dichromate will stay as the orange dichromate. It won't be reduced to the green chromium. So before I finish, I'll just write that down. So test for a primary or secondary alcohol. What you can do is you can warm with acidified potassium dichromate, and you'll get a color change from orange to green. Okay, more detail on oxidation of alcohols in the next video then.